Okay, we are now in the second chapter of Algebra 2. Can you believe it? Chapter 1's already over. So just a couple quick things before I get on with the first lesson in this chapter. Just so you know, this chapter is all about lines and functions. So this stuff right here. I have a little pointer tool I can use now. Things we're going to do. So things we will do, we're going to find the slope of lines, something you did in Algebra 1, so it might be somewhat review, but we will do it again, so please take notes on it. We will also evaluate functions. So basically, if x is 5, what's y? That's what that kind of stuff. It'll be a little bit harder than you had in Algebra 1, though, so don't assume it's going to be a cakewalk necessarily. Graph lines, again, something you did in Algebra 1, but still something we're going to go a little further with than you did in Algebra 1, so be ready. And then graph functions. So there's other types of functions besides lines. We'll see a few of those in this chapter. So let's move on to this lesson. And by the way, here's one thing I just discovered. Instead of having a white background, I can make it a notebook background. I can make it like graph paper, or graph paper with the coordinate grid. I'm going to leave it like this to show you the next part of this lesson. Okay, so the first thing in chapter 2, the word relation. So in math, what is a relation? Well, think about people, right? A relationship involves more than one person, right? It could be friendship, dating, whatever, something like that. So a relation in math also involves two things, mainly input and output values. So this is the textbook definition of what a relation is. What this basically means: input is always x, output's always y. And in ordered pairs, think back to Algebra 1, just the point x, y, right? You just graph that point. So here's an example of one. So here's my relation. I have the points 0, 4. I have the point negative 2, 3. The point negative 1, 3. The point negative 2, 2. And the point 1, negative 3. So this is a relation, just a bunch of ordered pairs. Again, a set of ordered pairs. And I can show this in a few ways. Here's one way to show it, just all the points listed out. I can also make this a graph. So don't forget that this first point, 0, 4, that means x is 0 and y is 4. So I go over nothing, up 4. There's that point. Negative 2, 3, that's back 2. And up 3, so it's right there. I'm going to say right there. Negative 1, 3, so it's back 1, and then up 3. So it's right there. Why is this not graphing? There it is. Negative 2, 2 is right here. Come on. Having some trouble here. My finger is dragging on the screen. Okay, and there's 1, negative 3. So the point right here, for some reason, is not showing up. There we go. Okay, so I've graphed those 1, 2, 3, 4, 5 points, all right here. So anyways, this is the graph of this relation. I also have one more way to show this. So I'm going to leave those points right there. I can also do what's called a mapping diagram. So mapping, it basically just shows a map from x to y. Because again, I really want to emphasize, and please do your notes, that x is the input and y is the output. So you plug in x first, then you get back your y. So I just set up the mapping diagram. I have a column for x right here, and a column for y right here. So my domain, I haven't defined that yet. So domain is another word you'll have to know. So domain as in DOMAIN. That's the entire set of all inputs. So domain is all inputs. That's just all x's, basically. So I have a 0. I have a -2. I'm just listing them all here. I have a -1. I've already listed -2. I don't got to repeat for this one here. And then I have a 1. So I'm going to move this a little bit. Okay, I also have a 1. Now for y's. So y, the set of all outputs, is called the range. So R-A-N-G-E. I know that looks pretty bad. The range is just all of the outputs. So think about it. You plug in an input and you get back an output. Let's try this again. Thought I was doing better last time. The handwriting's still a little bit sketchy. Anyways, so with the y's, I know I have a 4 from right there. This one was a 3, so I'm going to also include that. I have another 3, so I have 2 different 3's. I don't repeat myself. I keep the same. I'm just listing all the ones that exist. I have a 2, and then a -3. So now I have this down here. Here's what I know. 0 goes to 4. So I just arrow over 0 to 4. -2 goes to 3. Just arrow over. -1 also goes to 3. So I just show where it's going. It goes right there. -2 goes to 2. So I again arrow over, showing where it goes. And then 1 goes to -3. So this is called a mapping diagram, this diagram right here. And that's exactly what I did. I basically mapped, think about directions, right? I just gave the directions for where you go. When you plug in a certain x, like for example 0, I get back a certain y, here being 4. So get this down in your notes, and then I want you to try one more of these, and then we'll move on to something else. So for this example, I'm going to give you a relation. So again, a set of ordered pairs. I want you to graph it, plot the points basically, and also map it, just like before. So here is the relation. So I've given you a relation. It's just a set of ordered pairs. So you see I have 1, 2, 3, 4, 5 different points. And again, these are all my x's, the ones I kind of use this dark blue color for. And then this orangish red color are these y's right there. Let's go ahead and graph this. So I'm going to do here is draw my axes as an x-axis and y-axis. And what I'm also going to do is here I'm going to make every square 2 spots. Just because I have some larger numbers here than the screen I have. Anyways, -1, 5. It's this first point right here. That means I'm going to go over -1/2 because it's by 2 now, and up 5. So up 2, 4, so it's right there. There's my point. Then I'm going to graph 0, -3. It's going to be about there. Again, every single square is only 2 spots, so it's right about there. 1, 2.5. So that's going to be about here or so. It's kind of hard to pinpoint with this iPad stylus, but I'm trying. 0, 4, right here. And then 7. So that's going to be over 2, 4, 6, 7, and then up to 4, 5. So right about there. I'm going to plot that point. Must change my colors. Oh well. I'm going to plot that point right there. So I have my 5 points plotted. Again, it looks somewhat sketchy, but the iPad stylus I have isn't the best. So now let's draw the mapping diagram. So first of all, I do need my X and Y input output. Also, let's try that again. So also my domain and range. So with X's, I've got -1, 0, and 1. So I'm going to put all those there, -1, 0, 1. I have another 0. It's a repeat, so I don't show it again. And I have 7. Then for my Y's, let's use yellow. I have 5. I have -3. I have 2.5. I have 4. And let's move that a little bit. And I have 5 again. But I already have 5 right here. So I don't need to show it again. So anyways, -1 goes to 5. So there it is, just showing the map of how it goes from input to output, domain to range. 0 to -3, so again, straight across. 1 to 2.5. This one also is somewhat straight across. A little bit down because I drew it a little bit off. That's fine. 0 to 4. So 0 goes to -3. It also goes to 4. And then 7 goes to 5. So what I have here is two different x's. So -1 and 7 both go to 5 for y. And this 0 for x goes to -3 and also goes to 4. With relations, that happens sometimes. Just, again, that's all I'm doing is just representing the function and how the x's and y's, the inputs, outputs, domains, and ranges relate to each other. And there's also a special type of relation, which in Algebra 2 and Pre-Calc and going beyond you'll learn more about, but we will get into it this chapter, and that's called a function. So a function, I'm going to put the definition up here for you, is a special type of relation. Okay, I'm not exactly sure where my mic cut out, but let's start over again. So a function is a special type of relation where each input only has one output. That's kind of the book definition. What that basically means is every x only has one y. Or in other words, x has to be faithful. X cannot be a cheater. So it's a special kind of relation. Again, get it? Anyways, where x has to be faithful to y. If one x pairs with two different y's, then it's not a function. I'll show you an example of that right now. So here's my relation. So the example is this relation, a function. So I have the 0.26, the 0.36, the 0.45, and the 0.78. And I know it's kind of confusing. You have a lot of commas here. So that first comma in the parentheses separates x from y. This comma here just separates each ordered pair, because each ordered pair goes together. So anyways, here's how I can figure it out. So my x's, I have 2, 3, 4, and 7. In this relation, I have 4 different distinct x's that never repeat. So I have all different x's. So of course then, every x only has one y. Now I know that 2 goes to 6, so when x is 2, so if I map this, when x is 2, y is 6, and when x is 3, y is 6, that's okay. Because again, the x's have to be faithful. and only have one output. The y's don't. It's kind of double standard. That's just how it is with functions. So these can both go to y, the same y, and that's fine. So this is a function. So yes, this is a function. Let's see one that isn't. So here I've got a relation with these 1, 2, 3, 4, 5 points. The same 5 points from a few examples ago. So is this a function? Well, quickly I can figure this out. I'm going to map this. Again, map it. I just list all my x's, my inputs, list all my y's, the outputs. So for x's, I got -1, I got 0, I got +1, I got 0 again, don't say it again, don't repeat, and I've got 7. For the y's, I've got 5, I've got -3, I've got 2.5, I've got 4, and I've got 5 again. So again, do not repeat. I'll just use that same 5. So now I just draw the map. So -1 goes to 5. 0 goes to -3. 1 goes to 2.5. 0 goes to 4. So 0 also goes to 4. And then 7 goes to 5. So we already drew this map before, so you might already see in your notes, but notice here that this x has 2 different y's. It goes here, and it goes here. So x here is basically a cheater. It has 2 different y's. So the same input that was spelled wrong. So the same input has 2 different outputs. And again, 2 different outputs. I may once in a while throw the same exact point in the relation twice to trick you. But if I had like 0, -3 and another 0, -3, that's fine because it's the same x and the same y. It's just showing it again. It wouldn't make any difference. But in this case, I have 0, -3 and I have 0, 4. So that 0, that x input has 2 different outputs, so this would not be a function. So it's still a relation, right? It's a collection of ordered pairs, but it's not a function. So it's just a relation, but not that special type that makes it a function. So a couple more things, and I'm done. So this time, instead of giving you a bunch of points, I gave you a graph. Again, x goes left and right, y goes up and down. Is this a function or not? Yes or no? I'm going to use what's called the vertical line test to figure this out. So vertical line test. So what I noticed right away, I'm going to draw a vertical line here using this red color. So when x equals 4, right, I have all of this right here. Look at what y is. When x is 4, y equals 1, 2, 3, 4, 5, 6, 7, y equals 3, and y equals 2. So right there. So the points 4, 2, 4, 3, and 4, 7 are all in this graph. So the same x has not 2, but 3 different y's. So this would definitely not be a function. So basically what the vertical line test is, I just draw a line straight down. I can draw a bunch of lines straight down, and anytime I hit the graph more than once, so there 3 times, here I only hit it once, that's okay. If I hit the graph more than once, then it is not a function. So this graph here is not a function. Whereas this graph would actually be a function, because no matter where I draw my vertical line, I only hit the graph one time. So I'm going to draw a bunch of vertical lines. Well, vertical by hand. They're obviously not vertical, but I'm trying. So no matter where I draw a vertical line, I'm only hitting the graph at one spot with that vertical line, which here means that every x is faithful, right? Every input only has one output. Every x only has one y. So this would be a function. So this video is over.